Why is the car industry in crisis? And can crisis reinvent the car? The history of the automobile shows it's not just a story of ingenuity and engineering breakthroughs. It's also a story of crises. Oil shocks made fuel efficiency imperative. Dieselgate forced car makers to tackle emissions. And today, the industry is at a historic turning point with electrification, software, geopolitics, energy security, and Chinese competition converging all at once.
This is the largest transformation of what we have seen in the automotive industry.
It's an extreme crisis because it's not just one front like the oil shock.
I think this era is characterized by the number of changes that are happening at the same time.
So, why is the automotive industry in crisis? How do periods of disruption change the cars we drive? And what kind of car will emerge from this latest upheaval? Rev investigates. The car industry is entering a new phase. Electric car sales are growing, new brands are starting to upset the old order, factories are being retooled to accommodate new technologies, and car makers are pouring unprecedented sums of money into battery tech, software-defined vehicles, and EV platforms. So, why does it feel like the industry is in crisis? Because everything is changing. For more than a century, the world's biggest car makers built their businesses around the internal combustion engine, a technology that is now being made redundant in order to meet climate goals. It's an extremely expensive pivot, with major car makers having tentatively planned to double investment in EVs by 2030 to nearly $1.2 trillion. That investment could be essential for car makers to stay relevant, but success is not guaranteed. Despite higher EV volumes and revenue, Ford's electric vehicle division Model E was dissolved after losing $4.8 billion in 2025. EVs are not yet equally profitable for every player, and the question isn't simply whether electric cars will sell, but rather whether legacy car makers really can manufacture these EVs profitably, while their combustion engine models still make up the bulk of the profits. And that's while navigating shifting regulations and subsidies, fluctuating raw material costs, and high energy costs. Then there's China. Legacy car makers, especially from Germany, have lost the Chinese market, with domestic brands being seen as more tech-forward and innovative. At the same time, Chinese manufacturers are challenging legacy car makers in global markets with high-spec, low-cost EVs.
There's a structural change.
Economist Claudia Kempfert studies how energy, climate policy, and industrial transformation reshape economies. What car makers are facing, she says, is not a normal downturn, but a dramatic shift.
This means that the jobs of the past are not almost the same of the future. There will be more electric cars, more digitalization, battery production, and services.
The shift is painful because the old strengths of the industry don't automatically make it future-proof for this transformation, although not everyone dubs it just a crisis.
Crisis and opportunity, I would say at the same time.
Nikolaos Stefanos Koutrakis works at the Fraunhofer Institute for Production Systems and Design Technology. The Retronets project helps automotive companies in the Berlin region as they navigate this pivot.
When we shift from internal combustion engines to electric motors, a lot of products and components change. So if for OEMs the change is only in the production processes or in the product lines, for suppliers it's a lot more difficult to adapt.
And legacy car makers are having to become software companies instead of just vehicle manufacturers.
It's an extreme crisis.
Steve Fambro is the co-founder of Aptera, a US-based company that's developing an ultra-efficient solar electric vehicle. He sees today's crisis as a fight on multiple fronts.
It's not just one front like the oil shock. Yes, it is energy, but now it's also the labor model. It's actually two battles that the car companies are having to fight: the energy transition and I think the labor transition.
Car makers are going through a painful evolution. It's a crisis of profitability, technology, suppliers, skills, and competition all at once. But can pressure also force progress?
On the one hand, this is a huge pressure for competition. On the other hand, it is also a chance for more innovation and really disruptive innovation.
But this isn't the first time the automotive industry has faced a technological crossroads. At the beginning of the 20th century, nobody knew what would power the car. Steam, petrol, and electricity were all in the running. And for city drivers, electric cars had real advantages. They were quieter, cleaner, and didn't need to be started with a hand crank. In New York, electric taxis even used battery swapping more than a century before it became a modern EV buzzword. But gasoline had one decisive advantage.
What the gasoline cars gave at the time was a massive increase in range because you could bring the fuel with you in the cans.
Cheap oil, Henry Ford's mass-produced Model T, and the invention of the electric starter made petrol cars easier, cheaper, and more convenient to live with. Electric cars didn't disappear because the technology failed. They disappeared because gasoline addressed problems drivers had at the time. Although every time fuel became scarce again, it seemed like engineers returned to electricity. Even before the oil shocks of the mid-1970s, car makers across Europe revived the idea of battery-powered mobility. BMW had two electric 1602s as support cars during the 1972 Olympics in Munich. Opel's Electro GT set electric speed records. And in response to the energy crisis, Volkswagen experimented with an electric microbus, battery swapping, and later the Elektrogolf. None of these cars transformed the market, but they demonstrated that when energy security was under threat, the industry was willing to adapt and innovate. A few decades later came Dieselgate. This time the challenge was no longer simply how to use less fuel. Instead, the problem of emissions became more urgent than ever before. Electrification moved from the fringes to the foreground, accelerating the industry-wide shift we see today.
This is the largest transformation of what we have seen in the automotive industry, because it's not only to go away from oil. So there are so many different components, including digitalization and the software-based mobility.
Essentially, every automotive crisis has thrown up a new question for engineers to answer. First, how do we power a car? Then, how do we use less fuel? Then, how do we cut emissions? Today, the industry is being asked to answer all of these questions simultaneously. For over a century, the combustion engine shaped practically every aspect of a car, dictating the layout of the vehicle and the factories, the supply network, and the expertise car makers needed. The advent of the battery is changing everything, which means the car isn't simply being modified. In electric vehicles, the battery is the most vital component. It influences the floor of the vehicle, the weight, thermal management, crash safety, and ultimately what the car costs.
I think it's a redesign. So the big change is that we're not talking only about a vehicle, or we won't be talking about a vehicle, but a system of different components that need to be integrated together.
The second most important component, software. In older cars, software was tasked with individual functions, but it's now moved from a supporting role to shaping the experience of the car itself. A modern vehicle can incorporate up to 100 million lines of code, handling everything from driver assistance and infotainment to charging, battery management, cybersecurity, and over-the-air updates. So as parts of it can keep changing and evolving, the car is not a finished product when it leaves the factory.
Until now, manufacturers were focusing on the mechanical side of cars, so mechanical engineering most of all. But now software plays an equal part when developing the product and designing the vehicle.
AI enters the arena in two places. Inside the car, it supports driver assistance and future autonomy. Behind the scenes, it's increasingly used in manufacturing too.
We see it for autonomous driving, but it's not only used for the car itself, it's used for the manufacturing processes to produce the car. So it can be for digital assistance systems that will help workers with the introduction of new production lines, quality control, predictive maintenance, adaptive process control, optimization of manufacturing processes.
Production is one aspect, but the components essential to that process are equally important. EVs depend on battery cells, critical minerals, semiconductors. This is where China has become so important, creating a further challenge for European car makers.
We have China really investing into electric mobility, into batteries, into raw materials, and they really dominate the whole value chain of electric mobility, including digitalization and also the software-based cars.
For legacy car makers, the challenge is now to build not just an electric car, but an entire industrial system around it. One where the internal combustion engine, or ICE, no longer takes center stage. Right? If today's automotive transformation is so fundamental, you might expect car makers would agree on one clear answer to future technology. But while there is consensus that the old model is under pressure, the industry remains divided on what should replace it.
I don't think there will be one unified answer across everyone. Different manufacturers, different markets, different products, they're all approached through a different angle.
Each manufacturer is making a different assumption about the future, about customers, regulation, infrastructure, and how rapidly the world might evolve. Let's take a look at BMW. Its early forays into e-mobility were radical. The i3 wasn't a petrol car with a battery shoehorned into it. Instead, it was a purpose-built EV featuring a carbon fiber reinforced passenger cell. But BMW has continued to invest across multiple technologies, pursuing battery electric vehicles, plug-in hybrids, combustion engines, and next-generation EV platforms. A flexible approach that's helped it stay competitive. In 2025, BMW delivered over 600,000 electrified vehicles, of which over 400,000 were fully electric. Over in Japan, despite the success of the Prius hybrid, Toyota consolidated its multi-pathway approach with plug-in hybrids, BEVs, ICEs, and fuel cells, essentially different solutions for different regions. While EV adoption has progressed at different speeds, hybrids have remained a consistent source of sales, suggesting that Toyota's strategy is a resilient one. Meanwhile, Honda is a reminder of how quickly the tides can turn. After announcing a major EV push, the company has now cancelled the development and market launch of 3 EVs for North America and is reassessing its electrification strategy. It hasn't stopped working towards EVs, but has stopped betting on its previous EV timeline. It's a similar situation over at Mercedes and VW. Major manufacturers are adjusting their strategies based on policy and demand in real time.
What's interesting is how the electric vehicles are, and the industry is being crafted regionally for regional needs. Charging in China is so prolific, and of course the batteries are lower cost there because that's their origin, that efficiency doesn't really come into play because you can charge enough so frequently and so often. But in places like North America, you have fundamentally much larger distance to cover. In Europe, it's different. So I do think the solution is somewhat continental or regional.
That may be the key point. There may not be one single automotive future. The crucial question is not, will electric cars replace internal combustion engines? It's what mix of technologies will work best in what markets. Which brings us back to the question of whether crisis really can lead to innovation. Well, in various parts of the world, there are people trying to come up with different solutions to the car industry's various problems, and some are more radical than others. For years, the electric car debate has revolved around a single metric: range. How far can an EV go? The industry's answer has often been to make batteries bigger, but bigger batteries come with their own set of problems: weight, cost, raw materials, energy consumption. Has the industry been focusing on the wrong question? Instead of asking how much energy an EV can store, wouldn't a more important issue be how little energy it can use?
It's easier if you can just make the battery bigger, I think that's the old way of thinking. But I do think it's easier for companies to do that. And you can understand why. It gets products in the market quicker. It develops revenue streams quicker. But in the end, it ends up not being cost effective or not being profitable. So I think they're having to address the efficiency issue in order to get profitability.
Aptera is an example of an automotive startup taking a very different approach. Instead of asking how big a battery can be, it looks at how efficient a vehicle needs to be in order for solar power to be a viable solution.
We set out to say, how can we let the sun power the average American's daily commute? Let's say average is between roughly 35 miles, 40 miles. In order to do that, we needed to use 100 watt hours per mile. And in order to do that, we needed a very efficient platform. It just didn't exist. So we designed the vehicle to use that amount of energy per unit distance so that most drivers would be able to cover their daily driving needs just by solar charging.
That fundamentally different approach is reflected in the vehicle's design, with a focus on aerodynamics, low weight, and reducing the energy needed to power the vehicle.
Once we saw how much energy we received from a solar roof, my co-founder and I said, well, why don't we just make the whole vehicle covered in solar cells? Let's not only have a solar roof, let's cover the entire vehicle in solar and really see how much energy we can get. And so I think that all-in approach is really the only way to make solar-powered transportation work.
Of course, the broader point isn't that every manufacturer should necessarily emulate Aptera. Instead, efficiency could become the defining factor in the EV race too.
The cars cannot be always bigger and heavier, they should be smaller, and the batteries need to be recycled fully. So 100% recycling of the batteries is really important, but also the size. Of course, efficiency is a crucial aspect here, and also research to become less also resource dependent.
So the car of the future may not just be electric, it may also have to be lighter, smarter, less wasteful. These aren't entirely new ideas, having been pursued previously by various innovators within the automotive industry, whether it was the Sebring Vanguard city car in the USA, the River electric car in India, or the Buddy EV and Think City in Norway. However, with mounting climate pressures and natural resources becoming even more precious, the need for these vehicles is becoming more urgent. Looking ahead to the next automotive era, while range may still matter, efficiency is set to end up playing the most crucial role. So who will triumph in the next automotive age? Not necessarily the companies with the boldest prototypes, but those who can build the right technology at scale, at the right cost, and for the right market.
Scaling is a big issue. It might take more time than the actual solving of the problem. Because you need to change the manufacturing technologies and the processes that you have.
This is also where legacy car makers are trying hard to catch up with China.
It's a result of China's long-term industrial policy, because they heavily invested into electric mobility, into batteries, into circular economy, and all the rest. So they dominate all the value chain.
And it's where new priorities might become imperative.
Every automotive company that's building electric vehicles is focused more and more on efficiency, lightweight, low drag, motor efficiency, battery, electric conversion efficiency.
Which brings us back to the question we began with. Can crisis reinvent the car again? Maybe it is already doing that. When the old solutions are no longer competitive or sustainable, the industry is forced to innovate. Car makers propose new technologies, policymakers shape the market, consumers decide what they trust, and cost decides what survives. So the next automotive age may not be won by the cleverest concept alone. It might belong to the car that can be built at scale, sold profitably, and adopted globally. If history is any guide, crisis reinvents the car by changing what each new generation must prove it can do and be.